and welcome to Chapter 3. Alright, so we're going to do the following. We're going to take C4X13, so I'm going to copy that and put it in Chapter 5. So let's create a folder called CH5. In CH5, I'm going to paste C4X13, but I'm going to rename it C5X1. Alright, so in C5X1, what we're going to do is we're going to add to the tester a predicate method has solutions. Okay, what's going to happen is that, let's see, what is going to happen? Alright, this is what happened. Before, we entered literal input. If we entered 1, 2, 1, I think we had real rational equal roots, 1, 2, 0, real rational unequal roots, and 1, 2, negative 1, real irrational unequal roots. We avoided complex roots like the plague. Now, what we want to do here is allow complex roots, okay? So the problem is this. If the discriminant is negative, getRoot's going to have a problem. Because look at what the class looks like. GetRoot uses the discriminant and square roots it. Now, Java doesn't know how to square root a negative. You'll probably get an error called NaN, not a number. Not a real number, anyway. So that's an issue. So we're going to add to the test of the following. We're going to add a predicate method. A predicate method is a method that returns true or false. It's an accessor. I'm going to call it has solutions, and it's going to return true if the solutions are real. It should really say has real solutions. Okay. So let's do that. And so Chapter 5, we're starting out today, is all about Booleans and if statements and predicate methods, and a Boolean is any variable that's either true or false, right? And a predicate method is an accessor that returns true or false. So how about this? If Joey, remember the Joey object from last time, has solutions, then, you don't have to write the word then you can do this stuff. Okay. By the way, I'm recording after the fact. I forgot to turn on my mic, so I'm doing this over again. Sorry. All right, now the problem isn't this line, right? So I could leave it in here or take it out. It really doesn't matter. I'm going to take it out because the point is the if statement is guarding against square rooting a negative. So I can print a negative. Whoops. So let's put that there. That's okay. I can print that like a -8 or something. Whoops, I didn't mean to copy it. I didn't mean to cut it. So let me get rid of that. Okay. But now it'll only do solutions that are real when this is true. Now, what if it's false? Well, we want to have some kind of output, right? So this is going to be an if-then. You don't have to write then for the then clause. Else. So let's do an else. And in this case, we could get crazy and actually print out complex roots. I'm not going to get that crazy right now in the interest of saving time. I'm just going to print some message like the roots are complex conjugates or something. Something like that, right? Boom. All right, so there's an example of an if-then else. And you don't have to have an else. Sometimes it's just an if-then. You can leave this part out. So it'll print out the same roots we had before when we plug in 1, 2, -1, 1, 2, 0, 1, 2, 1. But when we plug in 1, 2, 2, that was the complex case. It won't give me complex roots, but at least it'll say something. And the discriminant is negative. I think it was -4. So all we have to do is write this predicate method in the tester. I'm sorry, in the class. This is the tester. So here's your new tester, okay? Anything we left out of here? Well, just for fun, last chapter we were talking about scanner to avoid Java seeing every time we want to change the input. How about we use parsed input? Here we go. This is what that means. I'm going to add a little something for input here. Let's say I call this A, B, and C, the coefficients of the quadratic equation we're solving using the quadratic formula. And what I'm going to do is I'm going to capture int a from arg0. But be careful, arg0 is a string. So you have to convert it to an int if it is. So let's say int a equals integer dot parse int of args0. So that'll take the first parameter from the command line after where you say, Java, after you Java C quadratic equation tester, then you do Java quadratic equation tester, right? Well, now you're going to do Java quadratic equation tester and then list A, B, and C. All right, so let's do that. Let's do 3 inputs. This will be B. This will be C. This will be args1. That's an array. That will be args2. A static string array, right? It's a string array called args. So sub 0 is the first one, a letter, the first input. Sub 1 is the second input. Sub 2 is the third input. All right. So that'll get the input as a string, convert it to an int, and then we plug the ints back into our constructor. The constructor's not changing. GetDisk isn't changing. GetRoot isn't changing. Nothing's changing. We're just adding this, and we're changing how we do input instead of scanner. And just for fun, let's do the header comments. Let's make this a multiple line header comment. Let's refresh everything we did in chapter 4. Purpose is find the roots of a quadratic equation. Using the quadratic formula, if you like to write that, that's fine. Required files will be this one. And this one. All right, translator. Remember, the translator line and the interpreter line aren't always obvious. Translator. To this one's nothing new. This one's a little different. Here you got to input A, B, and C. You're going to type numbers, but it's going to be inputted as strings. So if you type in 1, 2, 2, it's going to do string 1 in quotes, string 2 in quotes, string 3 in double quotes. Okay? There you go. And then those are the numbers you're going to input on the command line. They get inputted here, and you're good. All right, so this is done. So how do you write has solutions? That's the only new method we need to write. Okay, let's find out. Let's go down here. Let's add another accessor. You know what? Let me copy this, because it's another accessor. Return true. Okay, how about this? True if and only if roots are real. How about that? It's at returns true. Well, you know what it returns? It returns get disk is greater than or equal to 0. It returns if that whole thing. If this is true, that's what it returns. If this is false, that's what it returns. Now, I could return that, but let's be pedantic here and write another if statement, just to practice if statements, okay? So if get disk is negative, then return, well, that's when we don't have real roots, so return false. False is a reserved word. It's a type of the Boolean. It's a value of the Boolean type. Else, well, guess what else? Now, by the way, if you're only using one line here, it's not considered a block of code. You don't need the braces. They're optional. If you have more than one line in the then clause or the else clause, you need the braces. Be careful with that. I always put the braces there just to make it easy to read. And here when we return true, notice that's highlighted, color-coded there, so because it's also a reserved word. So let's save that, and now let's test it. All right, where's my terminal? Let's try this. Don't I have... There you go. All right, so if you Java C, quadratic equation tester, what'd I do? I did something wrong. Sorry, we're doing this a little bit too fast. We had no errors. Oh, silly. You know, I'm just cuckoo. I forgot one thing. This is not getRoot2. This is has solutions. And this is not double. This is Bullion. Silly me. Sorry, I meant to change that. And good. All right. And again, very simple. If, you know, this can just simply return that. That's much more elegant, but let's just practice if statements for now. Okay, so where's my terminal? There it is. Dun, 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 dun. All right, let's try that again. Java C it and Java it. So here we go. Now notice that's an error. Why? Because it's looking for args input. Okay, so how about 1, 2, 1. That was real rational equal roots. There they are. The discriminant is 0, root 1 and root 2 are real rational unequal. Good. How about this one? I think this was real rational unequal. So when the discriminant is 0, we have real rational equal. And when the discriminant is positive and the perfect square real rational unequal, there you go. And if it's a positive non-perfect square, I think that'll do it. It'll be 2 real irrational unequal roots. There they are. But now look what happens. Whoops! Now look what happens when you plug in 2. See, notice you can do all the input from the command line, and you're not using scanner. And there you go. The discriminant is negative, so the roots are complex conjugates. Perfect. That's it. All right. So that's all we did today. C5X1, the first exercise using if statements and predicate methods in Chapter 5. Now this reminds me of another program we wrote in Chapter 4 that we said was going to be a problem. Let's take a look at this. A program we said we needed if statements for, right? All right, let me get rid of this. Let me get rid of this for now. So this is what I'm going to do. I'm going to go back to Chapter 4. I'm going to take C4X5, I think it is. Is that the one? Data set, right. Let's copy that. And let's go to Chapter 5, put it in there. And this is not an if problem. I'm going to paste it. So I'm going to actually rename it C5X0. C5X0. Because we said something about C4X5 or C4X6 that wasn't true. Take a look at this. In this tester, we entered it in as many quizzes as we felt like. We could figure out the sum of the count and the average, right? But now I also want, I think this is actually C4X6. We didn't do it. Because, oh yeah, we need if statements. I don't think we do. We could use if statements. But think about this. Is there a way to keep track of the largest one and the smallest one, the largest quiz and the smallest quiz, without using if statements? That's why I'm calling it C5X0. It's not really an if statement question. So let me correct what we said. We don't need if statements here. Look, take a look at this. Let's add another print line. Let's see. How about, let's see, Control C that. All right. And let's see. How about let's print out largest and smallest. GetLargest, getSmallest, something like that. And the largest in this data set is what? 80? Okay. And the smallest in this data set is 50. Okay, let's see if we can make this work. So, how about this? Largest quiz, smallest quiz value, right? Then that getLargest, then that getSmallest. All right, and again, remember, all the work was done in added value, and the same thing's going to happen here. This is what we're going to do. Every time we add a new value, we're going to sum it, we're going to count it. Average is an accessor that just takes those 2 naughty bits and divides them, right? But now what I want is 2 more naughty bits, largest and smallest, that get changed every time we plug in a larger number or a smaller number than we have kept track of. Okay, so what does that mean? Well, let's save this. Is this done? I think we're good, right? Yeah, we're good. Okay. So let's go to data set. What I want to do is add getLargest, getSmallest. And what I need is 2 more naughty bits. All right, so how about this? Private. It's going to keep track, whoops, I'm going to keep track of the largest values so far. So largest and smallest. The trick here is to initialize large to something small so that if you find something bigger, you'll change it the first time and every time that it's bigger. So this dot largest should start out small. That's the smallest it can be, if it's a quiz, right? Okay, this isn't really data set, it's like a quiz average or something, whatever. But look at this one. How about this dot smallest? Now the problem with smallest is it'll never change if it's too small. All right, if I start it at 0 and I compare it to everything else, I can't figure out if it's smaller than 0. That's ridiculous. How about we make it 100, as big as it can possibly get in this particular universe, or in this the domain of this problem, right? So this is the key. Every time we enter a score with add value that's actually smaller than that, we'll change it. But then we'll keep on changing if it's smaller still every time, and reverse with largest. So here's the trick: without an if statement, let largest equal math.max of largest and score. So that every time the score is bigger than largest, it'll change largest, even if it changed already, even if it's not 0 anymore. That's tricky. And smallest will equal math.min of smallest and score. And this is commutative. You can write score, comma, smallest, I guess. And let's see how that works. All right, so well, let's save that much, but we still have to write the accessors, right? Let's write the accessors. Here we go. How about here? I'll throw it right in here. All right, this is an accessor that returns largest and public int getLargest and largest. We didn't get to do this in class. I meant to. Sorry, I've been sick this week, so things are getting a little bit kaflooey. And let's copy this. Put that in there. And this is going to return smallest. This is way back, well, we didn't have a lot of descriptors here. And get smallest. And return smallest. Hopefully I spelled everything right. This is in camel case, this is not. Well, it is, but there's only one word here. Okay, so save it. Now let's test that. Okay, so let's go back to the terminal. Let's cd ... So we got out of C5X1 and let's go into C5X0. There we go. And let's Java C dataset tester. Oh, forgot something. Sorry. This is, what is it? Largest. Largest. What did I do? Oh, here. Whoops, sorry. Semicolon. Ding. All right, save that. And sorry, I'm doing this a little quick because I should have done this in class, but I don't have a lot of time right now. Is that okay? We're okay. So run that. And the input's already in the tester. We're not using scanner or args. And 80 was the biggest and 50 was the smallest. So there's the logic. So you could use if statements if you want. You could rewrite this in chapter 5 using if statements. But why? There's no need to do that. And that's a common algorithm to deal with, to use with finding the maximum value of an array or minimum value of an array. We'll come back to that when we do with arrays. I think chapter 7 or 8. We'll get to that. All right, so that's good for today. Thanks for watching. This will be C5X0, C5X1 file. Okay. MP4 file. Thank you. Bye-bye. See you, YouTube.